Our producer has come in and given us a brief. She said, I love what you did. I want you to do more. So we've got our conditions. How about reactions? So she's told us that she wants us to create a system that performs a series of actions based on conditions and the current game state, so when the player clicks on an interactable. There can be many different types of reactions, such as play an animation, play a sound, display text on the screen, add an item to the inventory, disable a game object in the scene, and change the global conditions to acknowledge a pickup, and more. Any type of reaction, we need to be able to do it. Now, depending on type, some reactions must have an optional delay, whereas others must be instant. Each type of reaction will need its own custom editor, because we're going to have a bunch of different types. We want to be able to edit those types. We want to see them in the inspector. So each different reaction will need its own custom editor. So then our approach is we're going to make collections of reactions which will be encapsulated, initialized, and called as part of a reaction collection. This reaction collection script is will have a single public react function. Now we're seeing the same system now from the other side. So we're seeing this from the reaction side. The individual reactions will all be different classes inheriting from a base reaction class. And so this will maintain the key functionality across all variations of reactions and allow them to be treated as reactions due to polymorphism. Reactions will derive from scriptable object, which allows polymorphic serialization so that custom inspectors can be created based on the type of reaction. And we'll look at that a little bit more coming up. So specifically, our steps on how we're going to do this. And then we are going to look at the reaction collection script. If you're curious, it's going to be in scripts, monobehaviors, and in interaction. And we're looking for the reaction collection.
So we're going to run through this very quickly. As Adam already said, this is a monobehavior. So that means it's attached to game objects. And what we're going to do there is we have a reference from our condition collection to our reaction collection. You may remember it from the last phase. That's all that's required. So the most important thing in a reaction collection is the array of reactions. Now, these reactions, we're not storing an array of text reactions, an array of animation reactions, an array of audio reactions. We're just storing a single array of reactions. And we're able to do that through a feature known as polymorphism. So we're going to have a look at some slides and try and describe what polymorphism is. So polymorphism is related to inheritance. You may remember it. We looked at it before. Here we've got our slide. We've got a public class called enemy. Then inheriting from that, we've got enemies. We've got orcs and goblins. And inheriting from orc, we've got orc chieftain. What polymorphism says is that all things that derive from a class can be treated as an instance of that class. So all orc chieftains can be treated as orcs. All orcs can be treated as enemies. All goblins can be treated as enemies. So imagine you've got a situation where we've got our war chief, our orc chieftain, and he's going to do a big battle cry. And he doesn't want to find all the goblins that he wants to affect, and find all the orcs that he wants to affect, and find all the orc chieftains that he wants to affect. He just wants to affect all the enemies. So all the enemies get a buff from his war cry, and that's part of polymorphism. He's able to just search for the enemies, and they all get the buff. So we're going to do the same thing. We're going to take advantage of that with our reactions. Rather than store a different array for each reaction type, we're just going to store an array of reactions and then keep text reactions in there, keep audio reactions in there, keep animation reactions in that array. So the next part of it is we've got this start function. And the start function is going to loop through all of the reactions. And it's going to call their initialization function. Now you'll notice there's a little bit of extra code in there. There's a delayed reaction bit. Now, I don't want you to worry too much about that. That is the process of the delayed reaction hiding the initialization reaction from the base class. So we're not going to cover reaction hiding too much here. That's in the scripts if you want to have a look at that and find out what reaction hiding, what function hiding is, but we're not going to cover that here. So all we need to know is that all the reactions are getting initialized by this function. Likewise, we've got a public react function, and that's, again, looping through all the reactions, and it's calling their react function. So the reaction collection has a react function, and it calls another react function on all of the reactions. And again, the delayed reaction hides the react function from the base class and gives it its own. We're not going to cover that here. Don't worry about it. All the reactions are reacting. So why was it important that we can store all of those reactions in the same space? Well, other than it being neater, it's very useful for the inspector. So normally, if we just created an array of reactions and they weren't scriptable objects, then we could store a text reaction in there, an audio reaction in there, an animation reaction in there, and in the inspector, they would all be treated as reactions. We wouldn't see any variation in that. However, with scriptable objects, since our reactions inherit from them, when we store our text reaction, audio reaction, animation reaction, the inspector respects that and actually shows us the correct version. So that's why we're making sure all of our reactions are scriptable objects.
This is important when we get into actually trying to manipulate our reaction collections in the inspector, which is each one of our reactions will have items that are specific to that particular reaction. Text reaction will have a text field. Audio reaction will have an audio source and an audio clip. Animation reaction will have all sorts of things it needs. So if we were looking in the inspector and our reaction collection simply treated them all as reaction, we wouldn't have any of these fields available. We wouldn't be able to change or manipulate any of this material inside the inspector. So by using the scriptable object, we get the actual reaction, which allows us to be able to manipulate them in the inspector.
So further to that, I just realized we introduced the term serialization here without actually explaining what it is. So serialization is the act of saving information to disk. So you know when you have information in your inspector, and then you press play, and all the information changes as you play the game, like the speed increases, it decreases, and then you exit play mode, and it goes back to what it was before. That's because the data has been serialized. That's how Unity's inspector works. It uses serialization to make sure all the data stays the same. Now, if it was using non-polymorphic serialization, if it was just standard, then you wouldn't see anything regardless of what the actual types were being shown. You'd just see all the default reactions. But since scriptable objects support polymorphic serialization, you see the correct type.
Let's go ahead and do some editing ourselves. So let's navigate to the scripts editor interaction folder, find the reaction collection editor, and open the reaction collection editor script for editing.
So this is in the scripts editor interaction and then reaction collection editor. The vast majority of this script has already been written for you. It's all the same stuff that we've been doing before. We don't need to repeat that. We don't need to tell you about it again. But there's some new functionality that would be interesting to look at. So what we want here is when we've got our reaction collection, it's on a game object, it's a component, and we want to be able to add different types of reaction to that. So how do we determine what the type of reaction that we're adding to that component is? Well, we're going to use two methods. We're going to use a drop-down and a button. So the drop-down will show you all the different types that you can create, and then when you press the button, the selected reaction will be chosen. Also, we're going to imitate the inspector. Now, when you want to add a component, you can drag and drop that script onto the inspector, and it'll add the component. Similarly, what we're going to say is we want to be able to drag those scriptable objects, those reactions, from the project onto our reaction collection, and that'll add reactions to our component. So we're going to have a look at that. I'm just going to very quickly run through what's going on in the editor, but we don't need to worry too much about it. So again, this is an editor with sub-editors. So this time, the editor is a reaction collection editor. It has an array of reactions. So this editor needs an array of sub-editors, which are reaction editors. We've got a serialized property for the reactions, and that's what we'll be using to add reactions to. And on enable, we're finding the target, we're caching it, and we're finding the serialized property. We're also creating the sub-editors. And on disable, we're cleaning up the editors, just as we've done before. Let's skip down a little bit until we find some functions that are a bit different. So on Inspector GUI, near the bottom, you'll see we're dealing with a whole bunch of rects. Now, rects are an area on the screen represented by 4 numbers, sort of an x, a y, a width, and a height. And we're creating some areas on the inspector that we can use. So we're creating one rect for the drop-down and button selection, and we're going to create another rect for the area where you can drag and drop your scripts. So that is going to be what we're concerned with. We want to complete the functionality for dragging and dropping reactions onto a component. So let's scroll down a little bit more. And we've got the type selection GUI, so that's the drop-down and the button. And then we've got the drag and drop area GUI. So this is where it starts getting interesting. The drag and drop area GUI, that's just drawing a box on screen, and it's going to give it some text in the middle that looks nice. So we've given it the button text color, and we've made sure it's aligned correctly, that sort of thing. We have a private static function here called dragging and dropping. Now, I want to explain something before we go too far. I've made this static so that it's much easier to pull this bit out. If you want to, then you can cut pretty much this entire function out and use it in your own code, because I think it's a very useful piece of code. It's all the bare bones that you need for dealing with dragging and dropping in Unity. So what are we doing here? Well, first off, we're caching the current event in Unity. So the event class records what's going on in Unity, and the current event is what the mouse is currently doing, what the keyboard's currently doing, that sort of thing. And so we're going to cache that current event. Next, we're saying if the drop area, that area on screen that we were measuring, if that doesn't contain the mouse at its current position, then get out of here. We're not actually interested in doing anything. Next, we're creating a switch case block statement, and we're basing that on the current type of event. Now, the first case that we're interested in is if the event type is a drag that's being updated. Now, this occurs when you've already clicked on something in your game, in the editor, and you're currently dragging it. That's going to be the first thing that happens as the mouse enters the rect that we've set up. So we need to determine when we get there, is this drag valid? Do we want to accept this drag? Are the things that are being dragged appropriate for what we're going to use them for? And we're going to do that with this isDragValid function. Currently, that's blank. We're going to need to go and fill that in a bit, but let's see what it's being used for. Now, we've got the drag and drop visual mode being set. Now, this is the way Unity determines whether or not a drag can be accepted. So we're saying, set the visual mode based on whether or not the drag is valid. If it is, set the visual mode to link. If it isn't, set it to rejected. And then afterwards, use the event. We don't want to use that event. We do want to use that event, sorry. We don't want anything else to use it. Next, we're on to the next case, and that's when the drag is performed. So if the drag is performed, that means that the mouse button has been let go, and it's trying to release whatever's being dragged. So the first thing we do is we accept that drag and drop release. Now note that this can only be performed if an updated drag has been performed first and the visual mode is linked. So if the visual mode has been set to link, then we can get a drag perform event. If it hasn't, then we can't get this event. So we can assume that at least one drag updated has happened, and isDragValid has returned true. So we know that we can accept the drag. So what are we going to do then? We're going to loop through all of the objects that are being dragged. And for each one, we're going to cast it as a monoscript. Now, a monoscript is the asset type that you get for scripts. So when you create a C# script, you create a monobehavior or something like that. But they're all contained in an asset, and the asset that they belong to is a monoscript. Next, we're finding a type. And this type is going to be whatever the monoscript contains. So it's called script.getClass, and that finds whatever the class is that's contained within the script. So at this point, we've already assumed that it is a monoscript that's being dragged. We've already assumed that there is a reaction as part of this script. So now what we need to say is we found the type that this script has. Let's create a reaction of that type. So we're saying reaction, new reaction, and then reaction editor dot create reaction. That's the same pattern that we were using before. A reaction is created in the reaction editor through a public static function. Lastly for this for loop, I should say, we're saying the reactions property, add an object to that array, and the object that we're adding is the new reaction that we've just created. Finally, we have used that event, so we're going to say current event.use. So we've gone over how the dragging and dropping is happening. Let's fill in this isDragValid function. So we'll start off, we'll remove the stub there. We're going to remove return false. OK. So under what circumstances are drags going to be valid? Well, a drag could be multiple objects. So we need all of the objects that are being dragged to meet the same requirements. The things that we want to accept are the scripts that inherit from reaction. So what we need to do is loop through all of the objects that are being dragged and make sure that they are all reactions. So let's do that. We'll start off by creating a for loop. And we're looping between 0 and drag and drop dot object references dot length. Now the first check that we want to make is whether or not we're currently dragging monoscripts. If we're not dragging monoscripts, then we don't want to accept the drag. We don't want to try and add anything. So first off, we'll say if drag and drop dot object references, and then the one at index I, so object references I, dot get type, so what is currently being dragged, if that is not equal to, so I should say get type is a function, so it needs open close parentheses. If that is not equal to type of monoscript, then we're going to return false. It doesn't matter what anything else is. We found something that's not a monoscript, so we're not going to do anything. So if we're continuing on at this point, then we know we've got a monoscript. So what do we need to do next? Well, next we need to determine if it's a reaction. So we need to find the type that's contained within the monoscript. So let's create a monoscript, which we will call script. And we'll set it equal to drag and drop dot object references I as a monoscript. So as is a way of casting that allows it to not throw errors if it's wrong. So we've found the script. Now we need to know the type that's contained within the script. It's a type which we will call script type. There we go. And we'll set that equal to script.getClass. OK, so now we've found the type. We need to check it. So there are a number of functions that we can use to check what a type is. And we're going to use some of them now. So we're going to say if not script type dot is subclass of, and then we're going to say type of reaction. So what's that saying? If the script type is not a subclass of reaction. If it doesn't inherit from reaction, then return false. So this seems like we've covered everything. We've got to the state where we know whatever's being dragged is a reaction. However, we need to account for one more thing, and that is abstract classes. Because currently, we could happily drag an abstract of a reaction onto our script. And if we did that, we wouldn't be able to create it, and we get errors, because abstracts cannot be created. So we need to check that it's not an abstract. So if it is an abstract, we're going to return false. So we say if script type dot is abstract, and this is a property, not a function, so is abstract doesn't require parentheses, then return false. So if it is an abstract, return false out of this function. We don't want to add anything. So we've looped through everything now. We've gone through everything, and we still haven't returned false, so that means everything is acceptable. So at the end of the function, after the loop, we can return true. OK, so there's a lot of interesting stuff in this editor script. We don't have time to go through it now, but it's going to be great for you guys if you want to take away and look at it. It's a really interesting one. But for now, just save your script and return to Unity.
All right, back in Unity, I'm going to change my layout just to make it a little bit easier to deal with. We need to create, this is a test, so what we're going to do is sort of test what we've just done. So let's create a new empty game object, just in the scene, anywhere. So create a new empty game object. Let's add a reaction collection. So add our reaction collection. So we can see that our reaction collection now has the custom inspector that we've made. Let's navigate down to scripts. We want to navigate to scriptable objects. We want to navigate to interaction and then to the reactions folder. And then we can drag either any of these delayed reactions or immediate reactions onto it. I'm going to back out a little bit so we can see them both. And we can just drag these onto the drag and drop, and we can see it just adds them in. So any of these things that inherit from reaction can just be added by dropping them onto that drag and drop situation that we have there. The other thing that we can do is that we can use the pull down, so we can create an audio reaction and then hit add, condition reactions, add. So we've created a custom inspector that is quite versatile. If we want to get rid of them, we can simply hit the remove key, and then we can expand them and set the details on each reaction. We can set the audio source and audio clip and delay on our audio reaction. Our condition reaction, we can pick a condition. If we had, what else should we do? Is it picked up item? We can set the item to be picked up and the delay. So this is not only allowing us to see this in a nicer form, but also because of the polymorphic serialization, that we can actually see the details of each and every one of these in our inspector. So let's go ahead and delete that game object when we're done with it. Creating a specific reaction type. So what are we going to be doing with a specific reaction type?
Well, at this point in the project, we haven't actually made the text reaction. We're going to need to make that now. So what we're going to do next is go to the scripts, scriptable objects, interaction, reactions, immediate reactions, and you'll see that there's no text reaction yet. So that's what we're going to make next.
So let's go ahead and create a new C# script. And let's name that script text reaction.
So the first thing we need to do, remove the gubbins, yay. Next, we need to change, it's not a mono behavior that we're creating, it's a reaction. So we're going to inherit from reaction. And now we're going to create the public variables that will make up our text. So text needs to have an actual message to display. So that's the first thing we're going to do. We're going to create a public string called message. And we want to have different colors for the different characters that are speaking, so we're going to give the text a color. So we can create a public color called text color, and we're going to give that a default value of white. So that's equal to color.white. Lastly, we want to be able to delay the text appearing on screen. Now you notice that this didn't go in the delayed reactions folder. That's because we've created a class for managing all the text that we want to appear on screen, and that's going to handle all the delays for us. So the reaction itself doesn't need to worry about the delay. But we do need to actually tell it how much we want it to be delayed by, so we'll create a public float, which we will call delay. Now, that class that I mentioned for displaying all our text, that's called text manager, and we need a reference to it, so we're going to create a private text manager. And we're going to call that text manager. Reactions have a number of functions that we can override in order to initialize and set up reactions. So the first thing we want to do is initialize our code, and that's going to be done with a protected function, which we override, which returns void, and is called our specific init, I should say. That's specific initialization. Quite often, the shortcut for initialization is init encoding. So within the initialization function, we're just going to say text manager equals find object of type, and the type we want to find is text manager. Now we need to actually set up our immediate reaction, the thing that happens immediately as soon as the react function is called, and that is protected override void immediate reaction. So as I mentioned before, we've got this text manager to do all of the work for us. So all we need to do is say text manager.display message. And we need to pass it some parameters. We need to tell it the message we're going to display. We need to tell it what color to display the message in. And we need to tell it how long before the message gets displayed. That's the delay. So that's very, very quick, very easy. And you see how easy it is to make something that works as a reaction.
So I think this is really one of the key points, the key takeaways to the framework that we've made, which is when we're looking at some of those walls of text earlier on, and we're looking at custom inspectors, and we're looking at this framework, it does get relatively in-depth and can become complicated. But now you get into creating your game on the creative side, and somebody in your design department says, I want to display text along the bottom. I know that when we originally designed this, where they were going to speak, it's a bit confusing. I want text along the bottom. That's all you have to write. So you can come in, you can sit down, you can bang that out. Now if we want to come up with a new reaction that has a new set of public variables, a new set of public fields, does something simple, this is about the size of the script that you need to write.
OK, save your script and return to Unity.
So we've saved the script and we've returned to Unity. And then now we want to create the reactions. We want to go to the scripts editor interaction folder, and we want to make the text reaction editor. So we've made our text reaction, but we have not yet made the editor for it. So we're going to go ahead and create a new C# script, and we'll place that into the reaction editors folder. So coming back to Unity in our project, we're going to go to scripts, and we're going to go to editor, and we're going to go to interaction, and we're going to go to reaction editors, and this is where we would like to create it. So let's create a new, we can do it, C# script. And we're going to name that text reaction editor. And open that for editing.
Okay, so by default, the inspector is going to show all the defaults for a text reaction. And that might be fine, but it would be nice if we could see a sort of a multi-line editor for the message in case we want to display large messages to the screen. So what we're going to do here is we're going to quickly run through the extra bits that we need to do for that. But before we can do that, we need to do all of the serialized properties that we worked on before. So first off, we need the editor namespace. So at the top, using Unity Editor. We know this is going to be a reaction editor and not a monobehavior. So we're going to change monobehavior to reaction editor. We know that this is going to target a text reaction, so we're going to use the custom editor attribute. And that's the type of text reaction. And we are going to need some serialized properties. So what do we need? We need private serialized property. And we'll call that message property. And we're going to need another serialized property. And that is the text color property. And one more, we need another serialized property, which is the delay property. Okay, so let's make those strings for the names of the fields that we're representing. So private constant string, which is text reaction prop message name. So that's the long scripting naming convention that we've chosen to consistently recognize exactly what's in that variable. And we need to give it a value because it's a constant. So that is equal to the string message. Remember, that needs to exactly match what you wrote in the text reaction. Okay, so the next one, again, is text reaction prop. But it's the text color name. And that is equal to the string text color. Last one is a private constant string, which is text reaction prop. And that's delay name. And we get a capital R.
Nope.
Yeah.
Yep. Thank you.
Thank you. Okay, so for our initialization, a reaction editor has an initialization function, and that's a protected override void called init. And we're going to do the same thing that we always do with the serialized properties. That's message property equals serialized object dot find property, and we're going to give it the name text reaction prop message name. Next, the text color property. That's serialized object dot find property text reaction prop text color name. Finally, we want to set the delay property, and that is the serialized object dot find property, and we're going to give it the name text reaction prop delay name. Okay, so the next thing we need to do is we need to draw the reaction. Now, normally, when you're making an editor, you'd need to do a call to onInspector GUI, but we've handled all the boilerplate in our reaction editor. We're just doing the specific bit that relates to this reaction. So we're going to say protected override void draw reaction. Okay, so what we want here is we want to use a text area instead of a text field. That's what we're creating this for. We want to have control over how big an area we are drawing the text in. So to do that, we're going to start out with a horizontal layout group. So editor GUI layout.begin horizontal. And since we're starting a horizontal layout group, let's end that and then put our code in between it so we don't forget. So editor GUI layout.end horizontal. And then go back in between the two. So the first thing we want to do is create a label field. So we're going to give this label field a specific width, and this needs to be offset by a small amount. So we're going to create a constant for that offset. So if we go back up to our constants, we're going to create a private constant float. And we'll call that area width offset. Now this is because an area width is slightly larger than most default fields. So we're going to give that a value of 19F. This is just something that you need to offset the size of a label by in order that everything lines up. Don't worry too much about it. Okay, so let's go back into our draw reaction function and use that. We'll say editor GUI layout.label field. And the label we want to use is message. So we're going to use a string and give it a capitalization. So it's capital M message. Then we're going to assign a specific width, and we do that with GUI layout.width. Now the width that we want to give it is the normal label width, but subtract that offset that we put in. So that's editor GUI utility dot label width minus area width offset. Now, we've got the label, but we still need the text area. So on the next line, we'll say message property dot string value. I'm just going to tell you what to write here, and then we'll cover it afterwards. And that's equal to editor GUI layout dot text area. The first parameter is message property dot string value. The second is GUI layout dot height, and we need to determine a height for this area. Now we're going to do it in terms of number of lines. So we're going to create another constant. So back to your private constant floats and create a second private constant float, and this time it's the message GUI lines. So this is going to be the number of lines of editor text that the message will take up, and we're going to give it a default of 3. So that's 3F for float. Okay, so within our GUI layout.height parentheses, we're going to set the height to editor GUI utility dot single line height multiplied by message GUI lines. And that is the last parameter, so we don't need another comma or anything like that. OK, so what's going on there? So the function that we're using is editor GUI layout.textArea, and that takes in a string for what is being displayed, and it returns a string for what is displayed, what is currently in the text area. So if anything changes over the course of the frame, then it will update itself. And we're giving it a height based on the standard height of a line, multiplied by however large we want that text area. So we've now created our message text area, and the other two properties we just want to display normally. So we're going to use editor GUI layout.property field, but we don't want to do this on the same line, so we're going to do it outside of the horizontal layout group. So we're going to say editor GUI layout.property field. And the property we want to draw is the text color property. And then the next property we want to draw, exactly the same way, is the delay property. So that's editor GUI layout.property field, delay property. OK, so there's one more very quick function that we need to write here, and that is giving it a label for the foldout. So if you remember in the inspector when we were looking at reactions there, each of them was in a nice box, and they had foldouts, and each of the foldouts needs a label based on the type of reaction it is. So we need to tell it what that foldout should be. And for that, we just create a very short function, and that is protected override string. It's called get foldout label. And all we need to do here is return the label that we want to use. So we're going to use a nicely formatted string, which is text space reaction with capital letters and stuff.
Text reaction.
OK, so that's all there is to it.
So we're going to save our script and return to the editor, and we were going to open the security room scene. And in the hierarchy, we want to find the default reaction child of picture interactable, and we want to add the text reaction that we have just created and set the message of the text reaction to he looks pretty trustworthy. So seeing that in action, what we want to do is we're in the security room scene, and then we want to navigate to the hierarchy, and then we want to find the picture interactable. So we're looking for picture interactable. And then we want to find the default reaction. So that's the default reaction. And we want to add a new text reaction. And so we can either drag it on here, or we can pick text reaction from the dropdown and click the add selection. So we now have a text reaction, and we can set the details of that text reaction. So we want to say this to, we want to set this to, he looks pretty trustworthy. And we're not going to change the text color or the delay, simply just he looks pretty trustworthy, and we want to save the scene. So let's save the scene. Now we want to open the persistent scene because we'd like to test this. So let's go back to our persistent scene, open that up, because remember that in our architecture we run everything from the persistent scene. And then let's enter play mode. And we should be able to click on the picture and get a text reaction.
I saw it again,
Okay.
All right.